Hey everyone, and welcome. Today, we're going to break down one of the most powerful tools out there in modern software, Kubernetes. You know, it can feel like a total black box sometimes, but I promise, by the end of this, you'll get its core architecture, the brain and the brawn that makes it all tick. So let's dive right in. But before we get into all the heavy technical stuff, let's start with something a little more fun. You've probably seen Kubernetes shortened all the time, but have you ever actually stopped to wonder why? Well, it's actually a pretty simple numeronym. You just take the first letter, K, and then you count the 8 letters that are in between. That's U, B, E, R, N, E, T, E, and then you just slap on the last letter S. So you get K, then those 8 letters, and then the S. And boom, K8s. A classic bit of engineering shorthand. You gotta love it. Now, to really get why Kubernetes is such a big deal, we first have to understand the problem it's trying to solve. So think about a single Docker container. And look, it's fantastic. It's like having this one super skilled worker who can do one job perfectly because it packs up an app and everything it needs into this one perfect little box. A single worker is great, but what happens when you need a whole factory? You know, hundreds, maybe even thousands of workers. You need managers, you need a command center, you need a whole logistics network. So how in the world are you supposed to manage all of those individual containers at scale? How do you handle it when things fail, or deal with all the networking? And that is where using Docker by itself just kind of hits a wall. And this right here is exactly what Kubernetes was made for. It's not just another platform to run containers, it's a platform to orchestrate them. It's the factory manager, the command center, and the entire logistics system all rolled into one powerful package. It's what gives the whole factory a brain. All right, so let's start our tour right on the factory floor. In Kubernetes speak, that's the data plane, or what we usually just call the worker nodes. This is where all the action happens. This is where your applications, all nicely wrapped up in their containers, are actually running. Okay, so on every single worker node, you've got this little agent called the kubelet. The best way to think of it is as the on-site foreman. Its job is simple, but it's absolutely critical. Make sure the containers it's supposed to be running are actually running and healthy. See, in Kubernetes, your containers don't just run loose. They're wrapped up in something called a pod. And if a pod fails, the kubelet is the first one to know, and it immediately sends a report straight up to the command center. All right, next up, we've got to talk networking, and that's all handled by the kube proxy. This little guy is like the factory's traffic controller. Its whole job is to manage the network rules on the node. It makes sure every single pod gets its own unique IP address so they can all talk to each other. And when you need to spread traffic across a bunch of identical pods, kube proxy takes care of that load balancing, using the power of Linux networking to direct all the traffic. Right, and of course, something has to actually, run the containers. That's the job of the container runtime. And yeah, Docker is a common one, but the cool thing about Kubernetes is that it's super flexible. It can use other runtimes like Containerd or CRI-O as long as they play by the rules. This is the real engine that's doing all the heavy lifting right there on the factory floor. Okay, so we've seen the factory floor, the muscle. Now let's head upstairs to the command center, the brain of the whole operation. This is the control plane. Now it's not running your apps directly. Instead, it's making all the big picture, strategic decisions for the entire cluster. So the absolute heart of the control plane is the API server. I want you to think of it as the single front door for the entire Kubernetes cluster. Literally every single request, whether it's coming from you, another user, or even another part of the cluster, has to go through the API server. It's the gatekeeper for everything, validating and processing it all. So when the API server gets a request to create a new pod, who decides where it goes? Well, that's the scheduler. Its only job, and it's a super important one, is to spot new pods that need a place to live. It's constantly looking at all the worker nodes, checking their CPU and memory, and then it picks the absolute best spot for that new pod. It's the master logistics planner for the entire factory. Okay, but with all this stuff happening, how does the cluster remember anything? That's where etcd comes in. Think of it as the cluster's memory. It's this super reliable distributed key value store that is the single source of truth for, well, everything. Every single piece of configuration, the state of every object, it's all stored safely and securely right here in etcd. So a huge part of having a command center is making sure the factory is actually doing what it's supposed to be doing, right? That is the job of the controller and manager. Think of it as a whole team of floor supervisors who are constantly checking on things. It runs a bunch of different controller processes in the background. For instance, if you say, I need 3 copies of my pod running, the replica set controller will constantly watch to make sure that exactly 3 are always up. If one happens to fail, it automatically spins up a replacement. And that, my friends, is the magic of auto-healing. And it's a total game changer.
So this all sounds great if you're running your own servers. But let's be real, most of us are running in the cloud these days. So how does Kubernetes talk to all those specific cloud features, like a load balancer from AWS or some storage from Google Cloud?
This is where a special, optional component comes in, the Cloud Controller Manager. It's basically the bridge to your cloud provider. It knows how to translate a generic Kubernetes request, like, hey, I need a load balancer, into the specific API call language that AWS or Azure or Google Cloud understands. It's the liaison to all your external suppliers.
All right, we've met all the key players. Now let's put it all together and watch the magic happen. We're going to follow a single, simple request to create one pod, and see how the command center directs the factory floor in this perfect symphony of orchestration.
Here's how it all comes together. Step 1. You, the user, send a request to the API server saying, hey, I want to create a new pod. Step 2. The scheduler, who is always watching, sees this new homeless pod and immediately finds the best worker node for it. Step 3. The API server takes that decision and writes it down in etcd, our single source of truth. And finally, step 4, the kubelet on that chosen worker node sees the new assignment, pulls the container image it needs, and tells the container runtime to fire it up. And just like that, you go from a simple request to a running application. Pretty cool, right?
So, let's just do a quick recap to lock this all in. It really boils down to 2 parts. You've got the control plane, that's the brain, making all the decisions with the API server, the scheduler, etcd, and the controllers. And then you have the data plane, that's the brawn, all the worker nodes with their kubelets and kube proxies, actually doing the heavy lifting. Brain and brawn working together.
Okay, so this brings us all the way back to our first question. We've seen this whole complex system, this whole factory analogy. Why go through all this trouble to build this massive factory when we could just use that one skilled Docker worker? What do we really gain from all this complexity?
The answer is simple, because this setup gives us some serious superpowers that you just can't get otherwise. First, you get true cluster behavior. The scheduler sees the whole picture and manages resources across the entire fleet. Second, you get auto-healing. It's like having a system that just fixes itself when things break. Third is auto-scaling. You can just tell the system you need 10 copies of your app instead of 3, and it just happens. And finally, you get advanced networking and security, with sophisticated internal load balancing and security rules that a single container could only dream of. So, if there's one thing you take away from all this, it should be this. Kubernetes isn't just about running containers. It's about taking those individual isolated workers and giving them a collective brain. It's what allows them to work together as a resilient, scalable, and seriously powerful system. So I'm curious, what part of this whole setup do you think is the most critical for the kinds of apps we're all building today?